Okay, welcome to week 9. This will almost certainly be our last week with new content. It might be that this is our last class day with new content, but I don't think we're in that much of a rush. I finished all the prep for the Moodle site. There's more things in this more about exponents page. If I go there, then now quadratic formula, it turns out it really belongs here because it's about exponents. So I have added a few sections in the textbook here. And if you go to the videos for more about exponents, now there's a new section about quadratic formula and videos for that. So that's where we'll start today, because that's sort of where we left off last time. We had done things about the first 3, but using solving quadratic equations with square roots, and then eventually the quadratic formula. That's where we are. There's also a topic for probably Thursday, graphing parabolas. This is our final topic, and it's small. There's just one textbook section. Use either textbook. And the videos, there's not that many because it's just a small topic. And I have a whiteboard already and things like that. Even the My Open Math is just one thing to do. But it doesn't really fit anywhere else, so it's its own topic. I had sent out an email saying that you can now look at practice finals. So let me give you, thank you for the note in chat, Brenda. If you go to the welcome and syllabus in resources on the side here, then there's something now called practice final. So if you open this up, then if you haven't seen this yet, you get a spreadsheet. And when it finishes loading, you can scroll down and see all of the problems. It's not kind of formatted nicely on the paper because it's a spreadsheet, but there you go. And up at the top are these 2 green boxes. And if I put a different number in the top, oh, except it is frozen. Why is it? Oh, I have to sign in. That might be why. One moment. I have to sign in on my personal account because that's where I made this thing. Okay. Yep. Okay, so now if I change this green box, then all the numbers change throughout the whole thing. But all of my secret math done off on the side in the light colors here is making it so the problems work out nicely. If they're supposed to have whole number solutions, they do. And if they're supposed to have things that cancel nice or factor well, then all of that math will work out for you. So you can do a practice final, and when you're done with it, say, oh, let's change the numbers again, and watch everything change, and there you go. At the bottom are tabs. See these tabs down here at the very bottom? The second tab is the answer key. Whenever the problems change, of course, the answer key changes also. Whoops, and I didn't actually remember to make everything gray, so I will just do that. Okay. Then, not sure why, just gonna put check boxes there. Okay. So the heads up, the warning is if you find a test you like and then start practicing it, but don't print out the answer key, then the next time you load this page, it's going to have different numbers, including a different answer key. So when you make your own copy of this and do something, then on the test page, go File and download to a PDF. Or you could file and print, and one of the options should be print to PDF up here, Microsoft Print to PDF. So either way, you can save a copy of it and save both the test problems and the answer key, because they go together. And that way you can check your work. If you don't remember to print the answer key also, then you won't know how you did. So my hope is that I can just give you one of these, right? There's a third tab of sort of the printer friendly version. And say, let's fit to width with narrow margins, portrait. So I will give you a page that looks like this to do as your final exam. And it will be just like this. Everything is all happy. You'll have done lots of these before. No surprises. But I have to get permission from my boss to do a final exam that's not the official one. So she is looking at this. So far, she likes it. Hopefully she will approve it. If I have to make some changes, I will. But the goal is that you can do lots of practice finals and then not be surprised by the real final. Okay, any questions about that? Do
So I
a
get,
thumbs up or something if you're quiet. Yes, Anthony.
will you show me one more time how to print and I get how you can just go up to file and print on this page, but how do you do the answer key?
You go at the bottom to these tabs here, they're different pages, so go to the answer key one, and then the same thing happens. Now if I go file and print, it's the answer key.
Different tabs. I'm trying to see where. Will you go back a page?
Test,
Oh,
answers, printer.
oh, at the bottom. There it is. Okay. Test, answers. Yep. Okay.
Yep.
Thank you.
Okay, so there's another bit of department rules that I don't know the answer to. Again, my boss is checking into it. There are some of you who haven't been here in person. And the department has a version of a math e-final in Moodle. I'm not sure if it uses MyOpenMath or is just very similar. And if you are a Zoom student, then that's what everyone has been doing. I'm not sure if I can print this and send it to people who are online and have them do that, because it doesn't have a timer built in the way Moodle can do. So it might be that if you want to do this one, because this is, again, the thing that has as much practice as you want, you'll have to actually show up in person during finals week sometime. Preferably, Tuesday at 6 when we'd be meeting anyway, but not necessarily. There can be flexibility about that. So if you are wanting to take a final exam at home because you're an at-home student, then that is an option, but I cannot promise that you'll get to take this one. It might be one that looks different. Whereas I'm pretty sure that I can get this approved for people in person by the time actual finals week happens. So there we go. That's all I know. Any questions about that?
No.
Okay, so if we're ever bored and not sure what to do, then we can load this up and just have someone pick a problem to do and we'll all work on it. But for now, that's not why we're here. Okay, so more about exponents, where we left off. I will remember this time to put the link in the chat, so no one has to go to Moodle. We had done a bunch of stuff over here about what scientific notation is, reviewing decimal point scoots, what squared and square roots are, and how math with exponents work. And some of these were really boring, but the important one was this second property, that when you have a exponent to an exponent, they multiply. And this property 3, that if you have two things multiplied together with an exponent over both, then you can put the exponent over them separately. Those were the two that we used the most. They're kind of opposites, are that if you had a fraction, you could subtract, or if you had different parts in a fraction with the exponent over both, you could break the exponent apart separately. And we did a bunch of examples. So now we're going to actually use exponents with our quadratic equations. Was that enough review? All of you were here Thursday, but I can talk more if you want me to do some other problems or things like that.
I think we're good.
Yeah.
Okay, we'll be doing lots of exponents, so you'll get some of that review built in. Although we're not going to do some of the more esoteric things with fractions raised to an exponent, probably. Okay, so where we left off with factoring was we had our general strategy where we would take the equation, set it equal to 0. Here's the set it equal to 0 step. Factor the side that's not 0. And then say that if the whole thing is 0, then either one of them is 0. If x minus 3 is 0, then x equals 3. Or the other one is 0. If x plus 3 is 0, then x has to be negative 3. So two answers could work, plus or minus 3, positive 3 or negative 3. And if we go back to the top and say, what were we looking at? Then that makes sense, right? 3 times 3 is 9. And because a negative times a negative is positive, negative 3 times negative 3 is also 9. However, it's obviously much quicker to just start by taking the square root of both sides. I could say x squared equals 9. Take the square root of both sides. The square root of x squared is x. And if you take the square root of a number, we're having to add a plus and minus in front to say that, the plus and minus, they both work, because the negative times a negative would also be a positive 9. So there's a note here, train ourselves in the habit. Whenever we take the square root of both sides, that's a good time-saving step sometimes. But remember to put plus or minus, because either one works. We saw in some of the real-life word problems, the minus answer is often not realistic, and we toss it. Maybe it takes negative 3 seconds for the pipes to fill the sink, or maybe it takes minus 3 hours for the airplanes to pass each other or something. And it's the positive answer that has real value in the world. But for completeness' sake, we need to keep track of all of the answers. Okay, everyone with me so far, just with the stuff at the top, taking the square root of both sides of an equation.
Yes.
So we haven't done that before. We have that little caveat of be careful to remember plus or minus, but you could see that this could save us time. So let me get a little bigger. Here's one that's done for us. Somebody gave us the already factored equation of y minus 7 quantity squared equals 12. So somebody took the square root of both sides. Oh, that's a terrible square root. There you go. If you take the square root of a square, they cancel each other out. No one writes it like that, but they do. And if you take the square root of a normal number, now we're having to remember that the plus or the minus both work. So this left-hand side becomes just y minus 7, and we get plus or minus square root of 12. Now, square root of 12 is the square root of 4 times 3. And we could break that apart using that property we just looked at as the square root of 4 times square root of 3, and we get 2 times the square root of 3. So all of that is what's going on behind the scenes as we're moving from one step to another here. Then finally, we have a minus 7, so we need to, that's so thick. Okay, we need to add 7 to both sides. And then we get, that's still too big on it. 7 plus or minus 2 square root 3s. So we're just following along for now. But there's a few things that were tricky. Well, let me put the link in so a new person can join us. Okay. So one thing was we decided to take the square root of both sides. If two things are equal, we can do anything to both sides as long as we're careful. We had to note that if we take the square root of a positive number, that could be a negative thing. We had to there you go. Simplify square root of 12, because for some reason people think that this looks more simple than that, although I'm not sure why. And other than that, it was the same. We added 7 to both sides to get y by itself, nothing exciting there. Okay, questions about that anywhere in the process?
No.
So tell me, how should we finish this one? This time, somebody gave us a fairly complicated looking thing, but they gave us a hint that all this stuff on the left side was just x minus 5 squared. Let's double check that just to be sure. If I have x minus 5 times itself, and if I FOIL, we have the first, x times x is x squared. The outside, x times negative 5 is minus 5x. The inside is the same thing. And then 5 times 5 is 25, with negative times negative is a positive. So yeah, that's x squared minus 10x plus 25. That's the same thing. Okay, so we've double checked this step. That makes us happy. How should we finish this problem? I'm gonna slide the screen so that you can see the other one also at the same time. Type it in chat or call it out in your microphone. Assume Suka's pointing at the square.
Yeah, we can move power two next to the 18.
Yeah, I can take the square root of both sides. And that makes the x minus 5 not have the squared on it anymore. Because squared and square roots are opposite. And they get the square root of 18. Before, we were wanting to factor the square root of 12. Let's do a similar thing with the square root of 18. So the square root of 18 is the square root of, what should I put underneath?
6 times 2. Sorry, I mean 9 times 2.
9 times 2. I can always break things all the way up into my prime factors if I wanted. So 9.
Isn't it supposed to be a 2?
Yes, it is. I am thinking the wrong thing. Thank you. So all of that. Whoops, and I made a mistake over here. What did I forget?
Plus or minus?
My plus or minus, yeah. Because it's been years since I've done lots of these. Okay. And then at the end, you want x by itself, so let's add 5 to both sides. So we have 5 plus 3 root 2s and 5 minus 3 root 2s as 2 answers. Now, if you started with 6 times 3, that would still work. Let me do that tangent. Then I would just say there's no square happening in here yet, but I could break my 6 apart into 2 times 3. And now the square root of 2 is one thing, and the square root of 3 times 3 is another. And if I have the square root of something times itself, that's the thing. That's how we define square root. And by convention, we put the constant that's not in a square root in front and just switch the order of them. So the same thought happens even if you don't factor perfectly the first time. Okay, questions about that problem?
No.
So can you really not just like combine the 5 and the 3 square 2 or square root of 2? Or
I could turn it into a decimal. I could take my calculator and say 5 plus 3 times the square root of 2 and get an approximated decimal.
Oh, I see.
But that's the closest I can do to making a plain number. It's like, thirds and quarters, they just don't play nicely together, square root of
Right.
two things. Okay, so why would we want to do this? Well, the answer is because even though we spent so much time factoring, it doesn't always do what we want. Oh, that's big. Why did it get big? Strange. Okay. Let's try this our normal way. We have x squared minus 10x plus, if I take 18 away from both sides, I get 7. So what two numbers are there that multiply to be 1 times 7 is 7 and add up to 10, negative 10? The only factors of 7 are 1 and 7. So this isn't going to work. There's nothing nice to factor. I don't have anything friendly to put in here. 7 and 1 don't do it. That shouldn't surprise me since I've seen the answer. The things that go in these two spots are 5 plus 3 square root of 2 and 5 minus 3 square root of 2. So yeah, not gonna happen. So before we gave you kind of artificially friendly problems where this type of thinking would work. There were counting numbers that you could put in these spots without having to worry about decimals or square roots or things like that. But now not all of them will work out nicely. So here's a bunch that are probably not going to work out nicely. We have 6 of them to do. I hope I gave us enough room. If I had more time, I would have made these jigsaw puzzles, but I was working on your practice final spreadsheet. So you're stuck just shouting at me. Or you could take them yourself if you want. But they're arranged to be a little bit ascending order of how complicated they are. So for the first one, if I just take the square root of both sides, that doesn't help me. What do I need to do first?
Move 12 to another side.
Yeah. And here we have something that we'll get back to later. There's no answer. There's nothing that when I multiply it by itself is negative. Anything multiplied by itself is going to be positive because it either was positive or it's a negative times itself, so a negative times a negative. So not all of these things have answers. That one's just sort of first as a warning. This means that when you're doing homework and you think that you're stuck and there's no answer, that might be the answer, that there is no answer. So
So if we try to break something down and can't break it down, it doesn't have an answer?
that's not quite true. But if you get to something that looks like this, where something times itself is negative, then you can't multiply a number by itself and get negative.
Okay.
There'll be a little bit more about that later on once we get to graphing parabolas. So keep that kind of in the back of your head for later today or Thursday. This will be something that makes more sense once you see pictures and play with the graphing calculator website. But for now, just know that sometimes no answer happens. Okay, now we'll really start. If I take the square root of both sides, that 3 is gonna stick around and become like square root of 3, and I don't want that. So what should I do first?
108 divided by 3.
Yeah, if I divide both sides by 3, then my z squared is by itself, and that would make me happy. By the way, remember our divisibility rules. If I add up the digits to 108, 1 plus 0 plus 8 is 9, 3 goes into that, so 3 will go into 108. So this is going to work out nicely. So z squared, so that's going to be 3 goes into 108. Whoops, I'm writing a square root symbol instead of a long division symbol because I'm in my square root chapter. Okay. So 3 times 3 is 9. 3 times 6 is 18, and then I'm done. So I get 36. Okay, that looks nice. What's my next step?
Move power 2 to 36.
Yeah, if I take the square root of both sides, that will get rid of that squared
Square.
and just leave me with the z. And the square root of 36 is 6, except what do I have to remember? You're making the same mistake I did a moment ago. Yeah, positive 6 works, but negative 6 also works. Negative 6 times negative 6 also gets you 36. So z could be positive 6 or negative 6. And all of these, because they're equations, I can plug things back in. If I put in negative 6, does it work? Yeah, negative 6 times negative 6 is 36. Then times 3, and I get 108. Questions on that second one? Okay, same plot. I want to get that y squared by itself. Notice that there's no term that has just a number times y. So I know that if I can get the y squared by itself, the other side can just be a number, and then I can take the square root of both sides. If there was something here like 5y, then this wouldn't be the right plan. But the only y is a y squared, so I just need to isolate it and I'm happy. What's my first step?
I don't understand your question, teacher. Can you repeat again?
Tell me again?
Yeah, can you repeat the question again?
Yeah, I have two things attached to my y squared. There's a multiplication by 3/4 and there's a -3, which is the simpler one to get rid of first.
How I would move 3 to another side.
Yeah, let's move 3 to the other side. So then I get 3/4 times y squared. And 18 plus 3 is 21. Now I need to undo a times 3/4. So the opposite of that is divided by 3/4. Let's do that off on the side. 21 divided by 3/4. Now, of course, you could just do this on a calculator if you're really doing the GED, but let's put it over 1. How do we divide fractions? Flip the second one and multiply. The 3 is going to cancel. And we get 28. Okay, so I have my goal. I have y squared equals something. So now I am ready to take the square root of both sides. That gets y by itself. And I have to do a plus or minus. And what is the square root of 28? Maybe that one I can simplify. 28 has some factors. It's 14 times 2. That doesn't help me. I can take the 14 and make it 7 times 2. And then I can say the 7 stays inside the square root. But there's 2 2's, so they get to hop outside. And I'm done. Let me make it so it's pretty much all on the screen. Okay, questions about that one? So how are you feeling? Does this seem nicer than factoring? Taking square roots of both sides?
Um, I think I was understanding factoring a little bit more than this, but this is not too difficult to grasp. I think I like
wish I
factoring a
could
little bit
take
more.
a gazillion practice GEDs and tell you exactly why you need to know this. But we'll keep going. Certainly, just kind of watching it and having it go through your brain is good review for the other processes. And in a moment, we'll get to the quadratic formula and then everything will change. Okay, here I have something squared equals something else. So I am all ready to take the square root of both sides. There's no fussing about I have to do first. Let's take the square root so that squared will cancel out. And if I do it to one side, I have to do it to both. So we get x minus 3 is plus or minus the square root of 16, which is 4. How do I finish?
Move 3. Move minus 3 to another side.
So x equals 3 plus 4, which is 7, or x equals 3 minus 4, which is -1. And we can always check, if we put 7 in, 7 minus 3 is 4, 4 times itself is 16, that works. If we put -1 in, -1 minus 3 more is -4, and that times itself is also 16, so yeah, we're good. Okay, b plus 2, all of that squared is 40. Very similar. I'm all set up to already take the square root of both sides. I get a b plus 2. I get plus or minus, but square root of 40 isn't
Fine.
quite so nice. I'll get 4 times 10. And the 4 can just become a 2. So if I take away 2 from both sides, then b is -2 plus or minus twice the square root of 10, whatever that is. Ugly answer. Okay, one more. I don't see anything times itself here. Can I factor this so that it's p minus something times the same thing? I need a number that multiplies to 25. Or two numbers that multiply to 25 and add up to 10.
5.
5 and 5. And they're both negative, so that we have a -5 and -5 makes a -10. But a negative times a negative makes a positive for 25. Okay, so this is p minus 5 times itself. So if I take the square root of both sides, I just get that p minus 5. And the square root of 18, we've done that one already. That's 9 times 2. And the square root of 9 just becomes 3. Is that the very same problem we did up above and I didn't notice when I made my page? It is 5 plus or minus, oh well. My fault for not noticing, okay. So all of that is well and good, but no one really does that. There's a process called completing the square that used to make this a lot more useful in the days before calculators. And if you want, you can go to the textbook sections and read about that process. It's a way to take any quadratic and sort of adjust it so that you can make it a square equals a number, and then take the square root of both sides. So even the ones that don't have nice answers, like this one, you could solve and figure out what goes in those spots. But now we have calculators. So times have changed, you get to reap the benefits. And when we want to factor something so that it looks like x minus something, right, and x minus something else. So what goes in these spots? There's a formula that tells us. If you start with ax squared plus bx plus c equals 0. If this isn't 0, just move it to the other side and combine it with c, and then it is 0. We'll do that. Then I can find the answers. I can find what goes in these factor spots. I can find what makes 0 when I plug x in. Those are all different ways of describing the solution. Using this formula, that's a little complicated, but it's worth it, because now I don't have to factor anymore. So staring at this formula isn't helpful at all. That's like watching someone else do pottery. You have to get your own hands dirty. So let's first watch me a little more, and then you can try some. So bigger if I can. Make it bigger here. Okay. Which one should I solve? Maybe I can solve it by factoring. If I can, that's often fastest, because if you haven't noticed, this is a long formula. But if I can't factor it, then I don't have to give up and go home. Instead, I can use the quadratic formula. So pick one and I'll do it.
So 20, 20,
17.
20. I think that one, 20.
That one.
20.
20, yeah. Thank you.
20. We can do both. Okay. So let's start with 17. If I want to solve this, then I always want to get it to be something equals 0. So let's move that 2 to the other side. Does it help if I write minus 2 on both sides? Maybe not immediately, but when you're looking at this later on in review? Or should I skip the little red minus 2s?
No, it's good.
Okay, now can I just factor this? Can I say I need two numbers that multiply to be 6 times -2 is -12. And they add up to -1. Sure, I can do that. Does 1 and -12 work? No. 2 and -6 work? No. 3 and -4 work? Sure, ta-da. Those multiply to -12. The A
Part-
times C.
Part 3.
And they add up
Ooh.
to the B, right? The -1, the thing on the X. Because all of this was assuming you had ax squared plus bx plus c equals 0. So 3 and 4 work. So I will take this x and break it apart to be not just a minus x, but a plus 3x and a minus 4x. Because that's what the 3 and the minus 4 told me to do. Okay, that's a terrible x. Oh, wait. Then I factor these two and these two separately. What comes out of the first? 3x. What comes out of the second? Minus, oops, that's a 2x plus 1. And then lastly, I take the 3x and the minus 2 and unfoil. I'm not quite done, but I've done the factoring. So before I finish, any questions on the factoring? As a side note, one problem with the MyOpen Math homework is I don't get to see your scratch papers much. But hopefully yours are looking neat like mine, where things sort of line up the same. Right? And the zeros are more or less up and down from each other and so on. Readability will prevent careless errors, and careless errors are not good on the GED. Okay, now we need to finish. So what is happening if these two, when we multiply, are 0, one or the other must be 0. So either 3x minus 2 equals 0, or 2x plus 1 equals 0. So that means x is move the 2 over and then divide by 3. So x is 2/3. Or move the 1 over to be a -1, divide by 2. And x is -1/2. Do you need me to show more steps for how I got from here to here?
Yes, please.
Fine.
Okay, let me do it then. Do-do. Okay, so in the first step, I took the -2 and I moved it to the other side, or the +1 and moved it over. And then I did divided by. Oops, other colors. Then I did divided by whatever is next to the x. Is that enough explanation?
Yeah.
Okay, onward, number 20. Somebody is trying to trick us. We have to have a bunch of stuff equal 0, not 5. So let's undo their factoring. They tried to be helpful, but it wasn't. X times X is X squared. Outside, X times 7 is plus 7X. Inside, X times -8 is -8X. Last, 7 times 8 is 56. And now we're going to do a -5 on both sides. Well, we can also put these together. And we get X squared, oops. Minus 1X minus 61 equals 0. Am I going to get two numbers that multiply to -61 and add up to -1? Don't think so. This looks like something that factoring isn't going to work. So we'll grab the quadratic equation. I just said something, but I'm not sure you believe me. Is everyone okay of why this isn't a good candidate for factoring?
I'm not sure.
Okay, so back up here. Now we have our A is 1 and our C is -61.
Yeah.
So we want two things that multiply to get -61. And the number in the middle, minus X, is a -1. So 1 and -61, they multiply to -61, but they don't add up to -1. Does 2 work? No, it's not even. Does 3 work? 6 plus 1 is 7, so that's not divisible by 3. 4, no. 5, no. 6, no. 7, no, it's not some strange multiple of 7. 8, no. 9, no. 10, no. And now 10 times 10 is 100, so we're getting too big. So 61 is prime. There's nothing that works so that I could add them up and get -1. So I don't have any whole number answers coming. Which, the way these work, means that I have a kind of square rooty answer coming, probably. Okay, so now we get to demonstrate the formula. So I would take the moment to list out what is my A and what is my B and what is my C. A is 1, because there's a 1 by that X squared. B is -1, and C is -61. Everyone okay just with peeling off the numbers, of which 2 of them are kind of hiding?
Yeah.
Okay, now we're just plugging things in. You've plugged things into formulas lots. This is a new formula. The only thing that makes it different is it's often written with the plus or minus combined, just to save pencil. Okay, here we go. X equals, put my fraction bar, -b. So a negative of -1 is a positive 1. Then I could have a plus or a minus. I have a square root. What is -1 times itself?
1.
1. Now, I like to, in this list over here, put a minus for a C, Cause that's going to show up and it just helps me to do it without staring at the other stuff at the same time. So a -4 times 1 is still -4 times a -61. So what's 61 times 4?
244.
244.
Yeah.
And a negative times a negative is a positive. Okay. 2 times A, 2 times 1 is 2. Everyone okay with how I just did the plugging in step?
Yep.
Okay, so let's keep going. I'm not sure, by the way, why people write it this way. If I have fractions being added, and they have the same denominator, I just add across the top, right? So I can go this direction and break apart my quadratic formula with the plus or the minus and make it two things. Because that's usually what will happen. We'll have 1/2 and then, or whatever the denominator is when A isn't 1. And then we have the other part that's also over 2. So what's the square root of 245? Time to think a little bit. So square root of 245. It looks like it's 5 times something. What's 245 divided by 5?
49.
So 4. So 49. Ah, that makes me happy. Because then I can break that apart, since it's two things being multiplied under a square root symbol. And the square root of 49 is 7. And somehow the ancient powers that be decided that counts as simpler. So I wind up with x equals 1/2, and then I could add or I could subtract 7/2 of square root 5. You'll say, is that really the answer? Yep, that's all we can do. Okay, let me zoom out a little. Questions on any of that? So the good news is that you get to do stuff on calculators, whether it's our final or the GED. The GED has a few no calculator problems, but they will not be this. So if I wanted to, I could just bring up my calculator and say, what is 1 plus the square root of 245? Oops, 245. And then all of that, I'm going to divide by 2. Because at the bottom. And I get a decimal answer, which in real life is probably what you're looking for. And then I would want to do it again, and where that plus sign was, put a minus sign. And get another decimal answer. And make that bigger so you can see it. There we go. So as a formula, we can use the calculator and save all that time and effort. All you have to do is to figure out what the numbers are step and to plug them in the step. And then everything else, the calculator can do the work. And you might say, well, what if on my GED, their answer didn't look like a decimal? It looked like this kind of business. Well, I could plug all of this in the calculator and find the decimal that matched. So that doesn't slow me down much. So in real life, the quadratic equation is great. We've just spent lots of time learning how to factor, learning how to do things like that, right? Or learning how to do things like that. But if you can just say A is 6, B is -1, and C is -2, then you plug them in your calculator and you get the answers you want, and you move on with life and build your machine or whatever you're trying to do. So people love the quadratic formula. It takes something that used to require lots of factoring and turns it into the calculator's problem. Okay, let's grab another one. Oh, it is 7:10 actually. Does anyone need to take a break?
Yes. Yes. Cute.
How about I do one, because I don't need a break, and if you need a break, that's okay. You can always listen to the recording later, or it's just an example problem, who cares? When we finish the one I'm doing next, which will be one of these, then after the break, I want to do word problems. 'Cause that's what-
28.
So 28. Okay, let's try 28. So have a good break if you're doing a break, otherwise. I will keep going. Okay. My minus 10x is on the wrong side. Fix that. So now I'm set up, and that's not wasted time, whether I'm factoring or whether I am using quadratic equation, a quadratic formula. I need to get things in that format. Ax squared plus bx plus c equals 0. Okay, 5, 10, those look like things that aren't prime numbers. I think I have some hope for factoring this. 5 times 1 is 5. Are there things that multiply to 5 and add up to 10? No, now I'm not as happy. 5 times 1 is 5, but that adds up to 6 and not 10. So So I think my factoring is not going to work. Let me put that off on the side since I just said a lot without writing. So I wanted things that multiply to 5, but add up to 10. And the only factors I have are 1 and 5. So no factors add to 10. So factoring isn't my way to do this. Okay, well then I switch to the formula. So let's grab it again. They're pasted somewhere on. There we go. Okay, so I want to write down my A, my B, my C. And if you're like me, let's do our 4AC also. So what's my A, those of you who are with me, if anybody is? No, everyone's on break. Okay, well, for the recording then, A is 5, B is 10, C is 1. Four times A times C, 4 times 5 is 20, times 1 is still 20. Then I plug things in. Twice A is 10. I can break up the fraction into 2 parts. The before the plus and minus. And with the same denominator. The square rooty thing after the plus and minus. N over 10 is 1. Square root of 80. Oh, my mouse. There you go. Square root of 80 would be 8 times 10. Neither of those are squares. Let's keep breaking things apart. 4 times 2 times 2 times 5. So the 4 is nice by a thing. And there's another 4 is 2 times 2. And then a 5. So a 2 outside of square root and a 2 outside of square root and a 5 is stuck in. There we go. If I had known 80 was 16 times 5, I could have done that right away, but I don't have that in my brain. That's as good an answer as we'll get. If I wanted to use my calculator, I could do that. Oops. I copy that. -1 plus or minus. I could even back up a step actually, because if I was doing this, why would I do 11? So let's go up to the top, -10 plus or minus 80 over, I needed a negative sign, my keyboard is not reliable today, there we go. Negative 10 plus or minus square root 80 over 10, so there was one answer. And then the same thing with a minus. Both answers are negative, by the way, that can happen. Okay, I'm not sure anyone's back yet, so I won't quite ask for questions about this one, but I will go ahead and start preparing for the word problems. Learn problem. Oh, don't replace. Okay, I'm gonna pause the recording because I'm boring right now, and we'll come back when everyone's back from break.
This question, thank you.
Okay, so let's do some word problems. And word problems are nice because you really always want the decimal answer. Right? Nobody is going to want their employee to tell them, by the way, the machine will work in 3 plus or minus 4 times square root of 8 seconds. You know. So having the calculator do all the work is what these are designed for. Okay, I'm not sure why we need to know this, but here we go. In real life, we would be, aiming missiles or rockets or something, not just watching Margaret shoot an arrow. But here we go. Margaret shoots an arrow into the air. The equation for the height in feet is that stuff. Now, when they give you these equations, an easy thing to do is say what happens when time is 0, the moment that we start the story. If I plug in t equals 0, that makes this go away and that go away, and all I have left is height is 8. Does that make sense? Yes, because Margaret's really tall. When she lifts her hand up like this, that's 8 feet above the ground. So height of 8 at time equals 0 matches our picture. Everyone okay with that? I would recommend getting in that habit. When they give you a word problems, start out by saying, what happens if I set t equals 0? Does that actually make things nice? Okay, we're asked, when is the arrow 56 feet above the ground? So if that's what we're looking for, we'll plug it in for h. So now we have 56 is all that stuff. So if we solve that, we'll find out what time, what t, works for making the arrow 56. And in the picture, there's sort of a hint that it's the highest it ever gets, but we don't actually know that. Which is another thing that happens is don't let the pictures cause you to make assumptions that aren't really there. Maybe 56 feet is in here and it keeps going up. If 56 feet is that far, there's going to be another time it's 56 feet also. But that's okay, because we often get two answers with these types of things. Okay. I have this equation. Let me recopy it. So 56 equals 8 plus 64t minus 16t squared. I want to be ax squared plus bx plus c equals 0 format. So I could just move the 56 over. But if I do that, it's going to make this 8 negative, because I'm subtracting 56. And I have another negative here. So since I dislike negative coefficients, I'm going to move things all over to the left-hand side. You could choose the other way and it would work out the same. But I'm going to do a plus 16t squared and a minus 64t and a minus 8. So that gives me on this side, the t becomes positive. That makes me happy. The middle term is negative, but in this case, at least one thing has to be negative. And then 56 minus 8 is a positive 48. And I get 0. Everyone okay with that first step of getting all the stuff on one side so the 0 is by itself? Again, I made a choice. If you wanted to, you could write this as 0 equals negative 48 plus 64t minus 16t squared, moving the 56 from this side over there. And it would work out the same, but I will let you check that on your own some other time if you care. Okay, so I have this one here. What is my A? What is my B? What is my C? A is 16. B is negative 64. C is 48. I also like doing a 4AC, so 4 times 16 times 48. 4 times 16 times 48. Oh, and my keyboard not working. Okay, 3072. Now my setup for the formula is done. Questions about any of that? Everyone says they're good. Okay, so plug it in. X is negative B. Negative of negative 64 is a positive 64. B times itself. What is 64 times itself? Yuck.
4,096.
64. 6. 4,096. Oh, okay. And then I had to subtract my 4AC. All of that over twice my A, so 2 times 16 is 32. Come on, keyboard. Everyone okay with my plugging things in step? Okay, well now let's just try and remember this, and the calculator does everything. So 64 plus 4,000, square root 4,096 minus the 3,072. And all of that we're going to divide it by 32. Did I take things right? 64, 4,096, 3,072. Yeah. So I get 3 as an answer. Now I'm not done. I could also have the same thing, but that plus or minus be the minus. Then I get 1 as an answer. So after 1 second or after 3 seconds. So it must be this type of picture I described before, where after about 1 second, it's 56 feet. And then on the way down, after about 3 seconds, it's also about 56 feet. Pardon my bad artwork, but you can kind of see what's happening. Okay, questions about the archery one? Okay, I'll ask you a question. Do I have to use quadratic equation here? I got some nice whole number answers. Could I have solved this by factoring? Take a vote. Yes, no. Do you think we could solve this one by factoring instead?
Yes.
Yeah, whole number answers means we should be able to. Let's see how that could work. No. Come on, keyboard. I could have taken this thing and noticed that 16 is a common factor for all of these parts. It's 3. And then done my factoring and said this is t minus 3 and t minus 1. So t minus 3 equals 0, or t minus 1 equals 0. That means that t would be 3, or t would be 1. So I get the same answer. What I did though was I skipped a bunch of steps. Unless you've done enough homework that you could just do that in your head. So if you're fast at factoring, then maybe this is a quicker way to do things. But if you're not fast at factoring, the quadratic equation didn't really take up much more space. The calculator did do all the work. And I wasn't sure when I started that it was going to work out to nice whole numbers anyway. So the fact that I decided to do the factoring is sort of the benefit of hindsight. So that's why people love the quadratic equation. It's not that much longer even in the best situation. And it just always works. Okay, more than enough about that problem. Now we have a coin toss. The referee is flipping a coin to see who will kick off. He is a more reasonably sized person, actually kind of short. When he lifts his arm up, it's only 6 feet. Although he is such an oddly proportioned person that he doesn't lift his hand up above his head when he lifts his hand up. Kind of strange. Ignore that picture. Okay. There's a new equation. As before, if time is 0, does this make sense with the picture? That's a good thing to check. So if we get rid of the time terms, because we put 0 in and 0 times anything is 0, then the height is 6 when time is 0. And that does match. That's the 6 feet there. So we want to find when the coin is 18 feet above the ground. So we put 18 instead of h on the other side of the equation, and we solve for it. These are very strange example problems, by the way, because normally what you solve for is when things hit the ground, when height is 0. But we can solve for things being 18 feet up also, and that's okay. Okay, I will rewrite it. And I want everyone to tell me what to do. Enough of me doing all the work tonight. And as you've heard, my ears are a little clogged because allergies and stress and too much staring at the computer to get your final ready. But I will try and hear you as best I can. And I have. What do I do first to solve for this?
More, 18.
Yeah, move the 18 to the other side.
Yeah, before I was all fussy about which side, but there's 2 positives. So now I'm gonna have 3 negatives, but that's okay. I'll do it your way. Negative 12 plus 32t minus 16t squared. Now I can rewrite it if you want to be having this t squared first and the plain t second and the constant at the end. If you've done a few of these, though, you don't need to, because you can read even from this line what the A, B, and C are. So for ax squared plus bx plus c, what's the A and our B and our C?
So A is negative 16 t squared. B is the 32 t, and C is the negative 12.
Almost, we don't put the t's in. The a's are what's in front of the x squared or t squared or whatever, so it doesn't.
Oh, right.
So it's just the numbers, which is nice because we want to plug only numbers into the calculator. Okay, and because I'm me, 4 times A times C. So 4 times 16 times 12.
768.
7. Oh, okay. Okay, so let's plug it in. And if you're doing this at home a lot, you will soon just plug it right in the calculator. There's no real virtue to writing it down on your paper first, other than checking your work, which is a good thing on a test, but for homework, who cares? But since I'm lecturing, I'm gonna write it first. So we plug it in, x equals negative b, so negative of 32, plus or minus the square root, b squared, 32 times 32. 1024 minus this 4ac, all of that over twice a, so a negative 32. Everyone with me so far?
Yep.
Okay, so okay, so negative 32 and a negative 32. And this is 4,096 and 3,070. No, I'm sorry, 1,024 and 768. Okay. And then we want the same thing, but one of them to be plus and one of them to be minus. So we get 0.5 or 1.5. Does it make sense that we have 2 positive answers?
Kinda.
0.5 seconds would be very soon after he flips. So that's going to be here on the picture. And then another second goes by and it gets to there on the picture, and it's the same height 2 different times. So the good news is that's about as hard as they are. Let's review what our actual steps were. First, we have the fuss with things step to get 0 by itself. Then we have the identify A, B, and C step, so we can plug things in. Then maybe you have the write everything out on paper step, good to do at least at the beginning. Then you have the calculator does everything. And then you write your answer. Well, not too bad. To review everything we did today, we started by talking about when you had equations, if we could make it x squared equals something, or maybe something stranger like, where were those? A b plus 2 squared equals something, and then taking the square root of both sides could work. So that's a extra trick for factoring. And it lets you factor some things that you can't factor the old-fashioned way. But if you're going to do that, and it's a word problem, and real life is all about the word problems, then it's usually just as fast, if not faster, to skip the factoring altogether and plug things in the quadratic formula and just get your answer. Because hooray, calculators have been invented. Looking back at the Moodle, then there we go, square roots of both sides or quadratic formula. You have some extra textbook sections if you want to see how the textbooks describe what we just did. If you have favorite YouTube math people, then there's a few more things to look at here if you want. The link to the Jamboard we were just on. And in the homework, now you have quadratic formula. I'm not sure why they sometimes call it quadratic equations and sometimes quadratic formula. But they have using it and applications as two more homeworks there. So all of that is stuff you should be able to do if you happen to have time before Thursday. And when I see you on Thursday, we'll do the very quick bit about graphing, which is fun. We're going to open this calculator and say, we can plug in, let's just grab the one we did. Y equals 8 plus 64x. Minus 16x squared. And whoa, we need to zoom in. So that's a very steep arrow that the shape actually makes compared to the picture. She's shooting it almost straight up. Don't do that with an arrow. It's like throwing a firework on your roof, right? Okay, anyway, so we'll use this and we'll get to see how these shapes work. And it will be fun because it's fun to play with this toy and say, like, what happens if you get rid of that? Ooh, that happens, or so on. So we'll have a fun toy when we start out next week. If you want to get ahead, you could watch the videos and so on, but it's not that complicated. Any questions before we're done?
Not at the moment.
Okay, I'm gonna stop the recording. And since my busyness